Hi everyone, I'm Andrew Redden with the Join program here at Timescale, and today we're going to discuss the intricacies of what happens behind the scenes during a failover with your HA replicas. Database replication keeps a full second copy of the database always immediately ready to go. Whenever an operation is written to the primary, that record is streamed to the replica using Postgres's write-ahead log. Timescale deploys replicas in separate availability zones within the same cloud region, ensuring high fault tolerance. Even in the unlikely event of an entire AZ failure, the database still experiences minimal downtime. Replication is managed using Timescale's automated monitoring and orchestration system, which ensures seamless failover when needed. Let's take a look at what happens. Initially, client requests are routed to the primary node, but after a failover, Timescale's automated recovery procedures kick off. Tools like Patroni monitor the primary for responsiveness. If a failure is detected, failover is triggered automatically. The replica is promoted to primary by applying any remaining wall changes and switching to read-write mode. Patroni directly manipulates Kubernetes service endpoints, such as node port services, to ensure that client requests are redirected to the new primary. The endpoint associated with the previous replica is updated to reflect its new role, so no modification is required on the user's part. In the background, Timescale begins restoring redundancy. A new replica is created using wall files or from a backup snapshot. Kubernetes orchestrates this process to ensure consistent state and separate AZ placement. Streaming replication begins, synchronizing the new replica and primary seamlessly. One additional benefit of HA replicas is that we also allow client read requests to the HA replica via a second independent connection endpoint. However, it's worth noting that the separate endpoint becomes temporarily unavailable during failover to ensure that the new primary remains stable. Once the new replica is fully synchronized, the read-only endpoint is restored. With Timescale's failover automation, leveraging tools like Patroni and Kubernetes, these processes happen seamlessly, ensuring high availability and minimal disruption. Let's take a closer look at how non-HA databases compare to HA databases in key scenarios. First, let's talk about scaling resources, like CPU and memory. If you reconfigure a non-HA database's CPU and memory, you'll typically experience downtime ranging from 30 seconds to 5 minutes. The duration depends on the workload and server configuration. In contrast, an HA database handles scalings without any downtime. At most, users might notice a brief reset of their connections, but no service interruption. Now let's take a look at planned maintenance. For non-HA databases, downtime during maintenance varies. Sometimes it can be avoided entirely, but in other cases, you might see 30 seconds to 5 minutes of disruption. HA databases, on the other hand, are built to handle maintenance seamlessly. There's no downtime and users remain unaffected. What about unexpected failures? This is where the difference becomes even more apparent. For a non-HA database, server failures trigger a recovery process that can take several minutes and in some cases up to 20 minutes. If there's a disk failure or an entire availability zone goes offline, recovery involves restoring from backups. This process could take anywhere from minutes to hours depending on the size and complexity of the database. HA databases are designed to eliminate downtime in these scenarios. Failover is automatic, with the replica promoted to primary almost immediately. Even in significant failures, like an AZ outage, users remain unaffected because operations seamlessly continue on the new primary. Timescale's HA replication provides continuous availability, whether you're scaling, performing maintenance, or dealing with unforeseen failures. This makes it the ideal choice for production workloads where downtime is simply not an option. Thank you so much for listening, and I look forward to seeing you in the next video.